Hi, everyone, and thank you for joining me today for episode 838 of the People Behind the Science podcast. I'm your host, Dr. Marie McNeely, and today we are excited to be revisiting our interview with our guest, Dr. Jonathan Payne. Listeners, Jonathan studies the history of life on Earth. He's interested in the interactions between the changes in Earth's environments and the evolution of life on Earth. In particular, Jonathan focuses on large extinction events like asteroid impacts and volcanic eruptions and how these impacted life in the oceans. Now, in our interview, Jonathan shares some wonderful stories from his life and research. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to the People Behind the Science podcast. Today, I am looking forward to introducing you all to our wonderful guest, Dr. Jonathan Payne. So, Jonathan, welcome to our show. How are you?
Thanks for having me. I'm doing well.
Excellent. Well, Jonathan, we are delighted to welcome you to the program today, and I'm excited to introduce you to our listeners. So, listeners, a little bit of background here. Jonathan is a professor as well as the chair of geological sciences at Stanford University. He also holds a courtesy appointment in biology. He is a member of Stanford's Interdisciplinary Biosciences Institute, called BioX, and he's an affiliate of the Stanford Woods Institute for the Environment. Jonathan received his bachelor's degree in geosciences from Williams College, and afterwards he worked as a high school math and science teacher in Switzerland for 2 years before returning to graduate school. Jonathan was awarded his PhD in Earth and Planetary Sciences from Harvard University, and he conducted postdoctoral research at Pennsylvania State University before joining the faculty there at Stanford. Now, Jonathan has received many awards and honors for his work, including the Stanford University Medal for Excellence in Advising Undergraduate Research, the Charles Schuchert Award from the Paleontological Society, a Career Award from the National Science Foundation, and he's also been named a Fellow of the Geological Society of America, as well as a Fellow of the Paleontological Society. And in our interview today, we are looking forward to learning more about Jonathan and his work. But Jonathan, we want to learn more about you, both as a scientist, but also as a human being. So I'd love to start first by chatting about your life outside of science. So can you tell us how you spend your free time?
My free time these days is spent probably in a couple of ways. First of all, I have a family, a wife and 2 kids, Tessa, age 7, and Oliver, age 10. So we spend a lot of time as a family going to sporting events, traveling, playing Nerf basketball inside the house. Other than that, I try to get to the gym when I can, which varies depending on what time of year it is. I love to get out hiking and traveling when I can, again, usually with the family. Mm-hmm. And prior to family life, I used to spend a lot of time playing volleyball, but that's been traded off for these other, probably more worthy pursuits.
Gotcha. Well, the kids are almost to the age where they're good volleyball teammates, so you'll just have to make a little family team. So.
We're working on that. They're more enthusiastic about a few other sports, so I'm trying to keep up with them.
Gotcha. So do you have a favorite family travel destination?
I think the most exciting family travel that we've had was a quarter that I spent teaching in a Stanford program in Florence, Italy.
Awesome.
We brought the whole family, and the kids got to enroll in a school in Florence for 3 months. And on the weekends, we spent a lot of time on trains visiting a lot of the major cities of Italy, including Rome and Venice, and just had a fantastic time there.
That sounds wonderful, and it's great to get a window into your life outside the lab. But I do also want to talk about your work. So, Jonathan, how do you describe what you do in your current position to someone who's not familiar with your research?
The simplest way to describe what I do is that in my lab group, we study the history of life on Earth. And we're in particular interested in the interactions between how environments have changed at Earth's surface and how organisms have evolved. In many cases, these are things like asteroid impact events or large volcanic eruptions that clearly have large effects on the evolution of life. But there are also cases where the evolution of life itself impacts the planet. The production of oxygen gas, for example, by photosynthetic organisms, including all the plants on land. or the activities of animals moving through sediment and liberating nutrients back into seawater. So that's the basic goal of what we do. A lot of it ends up being focused on life in the oceans because marine life has actually, in the end, a better fossil record than terrestrial life because it's a place where you're in an environment often where sediment's being deposited. So as you die, you get buried quite naturally. And a lot of the focus has been on big extinction events. I've been very interested in trying to understand why there have been big catastrophes in the history of animal life and how ecosystems recover afterwards.
Very cool. Well, Jonathan, I love that your research really brings together a variety of different fields, including biology, evolution, geosciences, and others, to piece together some of these cool stories of Earth's history. And I look forward to talking more about specific projects, but I want to talk a little bit first about motivation. I think all of us could use a little extra motivation, especially on a Friday afternoon, perhaps. But do you have a favorite quote or a saying that really resonates with you?
I'm not sure that I have a particular quote, but the key thing for me is focusing on enjoying the process. I watch a bit of basketball, and I think it's the Sixers these days who are always saying, trust the process, because they went through a long interval of not winning games in order to be able to draft good players. That's not really how I do science exactly, but I do think the way that I stay motivated is to enjoy the process of doing science as opposed to focusing on the end results. And that's what I talk to my students about a lot. For me, the best part of my job is the opportunity to work with students and to watch them grow as scientists over a year or 5 or 10 as we work together and as I see them learn. And I think the key thing is you can't always control the outcomes if any particular project works or doesn't work, or if a grant application that you've submitted gets funded or doesn't get funded. But if you do it to the best of your abilities and you're doing good work, then over time, some of the grants will get funded and most of the papers will get published one way or another. So my hope is that over time, these things even out. I realize that the world isn't completely fair and that doesn't always end up being the case. But it's, I think, the most effective way to approach the process.
Certainly. And I think so much of your time as a scientist is spent in kind of quote unquote the process, not necessarily coming up with these great results and brilliant aha moments. So I think it is so important to enjoy the journey. So in addition to talking about motivation and the forces that keep you motivated in your everyday work, I'd love to talk next about some of the people that have motivated and inspired you. So Jonathan, do you have any particular maybe role models or inspirational figures that come to your mind?
For me, a lot of it's the people that I've had personal contact with. Certainly, I'm inspired by some of the great figures in science as well. But in terms of actually influencing how I think and what I do on a daily basis, I do think that my PhD advisor, a professor named Andrew Knoll at Harvard University, was really the person who had the single largest impact on how I think about doing science. And what impressed me so much about Andy was always that he didn't view science as something where you have your particular tool and you always apply it to problems, but rather that you had big questions and whatever tools you needed to use to answer those questions, you used them or you found someone who could help you get that work done. So Andy did everything from looking at the relationships of different parts of the tree of life using gene sequences to thinking about the early evolution of life on Earth from fossils and from the chemistry of rocks, to thinking about life on other planets. When I was a graduate student, he was working on one of the Mars rover missions and making decisions about where to go to take the photographs or to measure the sediments on the surface of Mars. And it was really striking to me just how Andy viewed asking the right questions as the key thing. And that once you ask the right questions, then you just figure out what tools you need to answer those questions. It really opened my eyes to the importance of, as a scientist, asking the biggest questions that you can and being really ambitious about how are you going to figure out how to solve them, and knowing that a lot of that comes down to teamwork, that Andy was always very good about involving a large number of collaborators because a team of people working together is always much more than the sum of its parts. The other thing that always impressed me about Andy was that he was always available as an advisor. So I always felt extremely well supported in that he gave me independence to pursue the questions I was interested in. But whenever I needed his support, he was available for a meeting, despite the fact that, of course, he's working on a whole bunch of different projects and had administrative roles at the university. So that level of professionalism I really appreciated, and it's something that I've tried to model myself with my own students. reaching sort of Andy's level of accomplishment and breadth as a scientist, I think is something that very few of us will ever achieve, but it's a great thing to be aiming toward.
Certainly. Well, it sounds like you had a fantastic mentor here in Andy Knoll. And in talking about your mentor, you mentioned this idea of thinking of big questions. And I'm always curious to hear about how scientists began to ask these questions. When did you first start becoming curious about maybe this subject in particular or science in general? So do you have a story for us or a specific memory?
I think I do. So I was born in 1975, and the earliest things that I remember reasonably well come from about 1980 or so. 1980 is when Mount St. Helens erupted.
Ah, yeah.
It's also when the group of scientists from the University of California at Berkeley, led by Walter Alvarez, a geologist, reported evidence of high concentrations of the element iridium in sediments deposited right at the time of the extinction of the dinosaurs. And they used that to argue that the dinosaurs were killed by a large asteroid impact, which at the time was a really radical idea. That came right in the middle of my dinosaur phase of child. Mm-hmm. I was fascinated by how the world works. And at that time, my dad was teaching at Colgate University. And that whole area, the bedrock is all fossiliferous marine rocks that are, say, about 370 or 380 million years old. So as a kid, I would go out and see fossils in the rocks around our house. And in fact, we had a family friend who was a geochemist at Colgate who took me and my little brother and his kids out collecting fossils. So right at that time, I was hearing on the news these crazy ideas about dinosaurs being killed by impact, and I was having this chance to go out and actually collect fossils. And I sort of vaguely understood that the hill that we lived on had been underneath an ocean a long time ago. I just sort of imagined seawater filling that whole thing up rather than understanding plate tectonics or understanding later erosion and everything. But it was something I was very curious about. I really then picked up on things when I got to college. So when I got to college, I knew that I really wanted to take a real paleontology class and learn more about fossils from a more professional perspective. And I didn't know if I wanted to do English or history or math or geology, but I took all the different classes. I think it was at the end of my freshman year and then especially at the end of my sophomore year when I was thinking about what I could do during the summer. And I figured out that if I wanted to be a math major, I could do research and sit in the math library over the summer. Or if I wanted to do geology, I could get on a project running around in the mountains outside of Yellowstone in Wyoming.
Right.
And I loved being outside. So I was sold on the idea that I get to travel to these places that I hadn't seen before. So that was a lot of what made the choice for me between geology and other fields was this opportunity to travel. So I did have a chance to do a project just outside of Yellowstone Park looking at glacial sediments and trying to figure out during the last ice age where different glaciers had been. And then after that, I got to do a senior thesis project in paleontology on fossiliferous rocks from the coast of Baja California in Mexico. And that really opened my eyes to being able to go overseas or at least outside of the country to do field work. So I love the cultural aspect of that, of getting to know faculty and students from the university in Ensenada in Baja California, and also the opportunity to travel and, again, see these places that I never would have seen otherwise.
Oh, that is phenomenal. And I understood you took a somewhat non-traditional path in that you spent some time teaching after college. Can you tell us what helped you make that decision of what your next step was going to be and what was going through your mind when you were making that decision?
As I was finishing college, I did think that I wanted to go to graduate school, and I did grow up in an academic family. My dad was a college professor and later an administrator. My mom had been a high school teacher and then later a teacher at the college level. My grandmother was a community college English teacher. I had been a camp counselor for 3 summers, so I knew that I liked working with kids. I had been a tutor during college, tutoring mostly math, and then later a TA for geology courses. So teaching seemed like something that I would really enjoy. I knew I wanted to go to graduate school, but I wasn't sure what kind of geology I really wanted to study. And I knew that I really wanted to travel more, that I'd really enjoyed the travel during college. So when I found out that there were these opportunities to be a teacher at an international school, that seemed to fulfill a lot in terms of getting a chance to work with young people, a chance to travel. And Switzerland geologically, of course, is pretty fantastic because there's so much that you can see just taking the train around the country. So I had 2 opportunities, one in Sofia, Bulgaria, and the other in Switzerland, and ended up choosing Switzerland. And it was a great experience. Mm-hmm. What I learned is that I really loved being in the classroom. I learned that I was terrible at controlling middle school students in the classroom.
You're not alone on that one, I think.
I learned so much respect for people who can manage classrooms at that level. I'm very, very fortunate that the students I teach here at Stanford don't need to be managed the way my seventh graders did in Switzerland. Mm-hmm. And that gave me time actually to think through what it was that I was really interested in. And what I found was that in my spare time, I was doing a lot of reading of books about evolution. And what I realized is I loved being up in the mountains, but in the long run, if I was going to do science and needed to think about the same subject every day, what I really wanted to do was to work on the fossil record and the history of life. So that was then how I chose to apply to graduate schools with a focus on paleontology.
Gotcha. And then you, as we mentioned in our introduction, were awarded your PhD there from Harvard. Can you talk a little bit about your PhD and then subsequent postdoctoral experience?
So after 2 years of teaching, I had applied and been accepted to graduate school and had met with my PhD advisor, Andy Knoll, whom I mentioned earlier. And I was really excited to work with Andy because he had just started doing some work on mass extinction events. And when I consulted with my undergraduate advisor, Andy had an unusual record of being such a broad scientist, and he thought that that would be a really stimulating program to join. As it turned out, there were some other people who were just joining Harvard at the same time when I arrived that made it an even better place to be than I had anticipated. So during graduate school, I had a great group of other graduate students and postdocs who were around doing all kinds of fascinating things, including studying these events we call snowball Earth, glaciations between, say, 800 and 600 million years ago. There were a couple episodes where it looks like the whole Earth essentially became glaciated, so that you had glaciers covering the continents even at the equator and coming all the way down to sea level.
Oh, wow.
So there's a group of students and faculty trying to figure out those things. There are a few of us working on extinctions and the evolution of animals and plants. And the really formative experience for me, and the thing that allowed the rest of my career, I think, to go in a way that I was really excited about, was an opportunity to go and do field work in China. So I knew I was very excited about this end Permian mass extinction event, which happened about 250 million years ago. So 185 million years before the extinction of the dinosaurs. It's clearly the biggest extinction event in the history of animal life. And at the time I was starting graduate school, it was still pretty poorly understood why it happened, and even less understood how ecosystems recovered afterwards. Mm-hmm. So I was reading the literature, trying to find a good place to study rocks deposited in marine environments at the right time. China had just opened up to the West about 15 years prior to that. And I found an American scientist, a guy named Dan Lehrman, who was a professor at the University of Wisconsin at Oshkosh at that time, who had done his PhD work in China, working exactly on the kinds of rocks that I was interested in. I reached out to Dan, and he was extremely generous in offering to not only help facilitate fieldwork for me in China, but that he was going to be there at the time that I was interested in working, and so we could overlap a bit, and that he would be happy to collaborate with me and share data and samples as needed. And that fieldwork led to a bunch of exciting findings. In some ways, the most exciting one was learning inadvertently that there were these huge disturbances of the global carbon cycle, right? And the global carbon cycle includes the CO2 in the atmosphere that controls global climate. It's the problem we have today of global warming from carbon dioxide being emitted from burning fossil fuels. Well, it looks like after this end Permian extinction event, there were huge disturbances to the carbon cycle lasting 4 or 5 million years. And I had gone into China mostly interested in looking at the fossil record, but I needed to get some chemistry from the rocks so that I knew which samples from different places were of exactly the same age. And this is how we sort of inadvertently discovered these large carbon cycle disturbances. That paper got a lot of attention, and certainly I think was more than a small part of being competitive for a job at a place like Stanford. And the other part of that project that was really fortunate is that Dan had done his PhD work in China thanks to his PhD advisor, a guy named Paul Linus at the University of Kansas, and a Chinese geologist, a man named Wei Jiayong, who was training a group of mapping geologists for the Chinese Geological Survey for the province of Guizhou, where we were working. So really, this all came out of this partnership developed in the late 1980s between Paul Linus and Wei Jiayong. And I was able to fit into that, got to make some wonderful friends. At this point, I now have, as one of my PhD students, the advisee of one of the people trained by Wei Jiayong.
Oh, cool.
So we're on our third or fourth academic generation of people working on these rocks in China. So again, the cultural aspects of this were as exciting and interesting to me as the science, that I've gotten to know people in places that I would never have the opportunity to get to know if I were just going over as a tourist. So as I was finishing up graduate school, I was looking for postdoctoral opportunities. My now wife, then fiance, was looking as well. And we had worked out a situation where she was going to postdoc at the National Institutes of Health in Washington, D.C., and I was going to do a postdoc split between Penn State and the Smithsonian in D.C. and travel back and forth. I had a wonderful postdoc advisor at Penn State, a guy named Lee Kump, who's now actually the dean of their School of Earth Sciences. And Lee was fantastic. He welcomed me aboard, taught me geochemical modeling. About 6 weeks into my postdoc, I got offered the position at Stanford.
Oh, wow.
My wife and I sort of talked over the options and ended up deciding that we were going to head to California once we had worked out a position for her here. And because the position at Stanford was going to be better for her than what was going to be her second postdoc in DC, we told Stanford that not only was I going to take the job, but I was going to show up 3 months later, which is unusual in academia. Usually when you get these positions,
you defer a semester or two, yeah?
Yeah, you show up 6 months later or often a year and a half later. So I must have accepted the offer in June or July and showed up in September. And in fact, I hadn't even worked out my startup funding with the dean. I talked to the dean at Stanford and she said, well, when you get here, we'll figure things out. Mm-hmm. I've told people I would never recommend that to anyone else, but Pam was good to her word. So I never feel like I lost out on anything by just showing up. But that's how I ended up at Stanford. Mm-hmm. Not exactly the plan, but it worked out nicely. And I've got great colleagues here, wonderful students, and it's an exciting place to work.
Well, that is an amazing story. Thanks for sharing a little bit about your own history with us today. But I'd love to talk next about one of these awesome projects you have going on in the lab right now. So is there a favorite one in particular that you'd like to tell us about today?
Sure. I think I'd like to talk about two.
Sure.
One is that for a long time, paleontologists have been studying the diversity of animals across geological time. And we have pretty good understanding of that. What we've started to work on recently is trying to understand how animal abundance has changed across geological time. We think from looking at the rocks that the abundance of animals actually declines after these big extinction events. So it's not just that you lose species, but there are actually just fewer animals on the land surface or in the ocean than there were beforehand. But it's a much harder thing to quantify. So we've been working in my lab a bit, and I have a PhD student who's finishing up his first year right now, who's starting to look at this by taking lots and lots of rock samples in controlled environments, looking at shallow water, tropical reef environments, and asking how much of the rock is actually made up of shells versus mud and other things. And what we're seeing quantitatively is that the amount of shell material drops off after these big extinction events. What we're going to try to do next is to then broaden that out to say, is it just after these big extinction events, or is there a long-term trend from less animal abundance to more animal abundance? The short answer is we know that, yes, there has to be an increase. If you go back 1 billion years, there were no animals on Earth. Mm-hmm. There are lots of animals on Earth now, so it has to have increased at some point. But we really don't know when in any quantitative sense. So I'm very excited about going after that because it's a really fundamental question. It actually doesn't require a lot of high technology to answer. It just requires a lot of brute force labor and maybe some clever approaches. These days, we can do things like text mining using computerized documents. So we could actually look at things like finding mentions of limestones and then asking how many of those mentions are tied to mentions of fossils versus mentions of, say, unfossiliferous, meaning no fossils. So my guess is that we'll be able to do this through a combination of sort of low-tech stuff of just taking samples and looking at them under the microscope and quantifying what's in them, and potentially high-tech approaches like mining the text of hundreds of years worth of published papers. That's one area that I'm really excited about just because I'm really curious about how animal abundance changes and what that's telling us about how ecosystems have worked over time. The other project I'm really excited about is trying to assess extinction threat in the modern. We've been working a lot on these ancient extinction events, and there's a lot of discussion in the media about whether we're in a sixth major mass extinction event right now. But it's really hard to quantify because The scales at which we work are really different. When you're looking at the fossil record, you're looking at timescales of hundreds of thousands to millions of years. When we talk about the sixth extinction, we're often talking about decades to centuries, maybe a millennium at most. So that makes the comparison challenging. The other thing is in the fossil record, we're actually mostly looking at the extinction of genera, which are groups of closely related species. Whereas when we look in the modern, because we have a lot more information, we are generally talking about species. And that actually makes the comparison challenging because you're not really comparing apples to apples. So we're working in the lab right now to figure out ways both of comparing the past and the present extinctions, but then also for the present, trying to figure out if we can use available data to assess extinction threat for species that haven't been assessed yet and might not be assessed anytime in the near future. This is generally not things like birds and mammals. Those get assessed a lot, but this is the vast majority of animal diversity on the planet are things like beetles or marine snails and marine clams. And those are groups where there aren't lots of experts. There's not lots of data on how they're doing, but they're a huge component of the diversity. So we really need to understand how many of them are threatened, and if so, which ones. So we've been playing around with some public databases of sightings of different species, trying to use those to see if we can rapidly assess species that won't be more formally assessed for a long time so that we can enable more rapid response. So that part is really fun as well because it has more immediate potential impact on the well-being of Earth and even the well-being of people. And it really helps put in perspective what we're learning from the fossil record.
Absolutely. Well, Jonathan, these are some really cool projects that you described. And it's funny to listen to scientists talk because both about your research and your career path, it just seems like as you're describing it, like everything just fell into place and worked out very nicely, right? I know that's often not the case in science. There are challenges, there are struggles, and there are failures along the way. And I think it's so important to bring those to light as well. So that's one of the things I love chatting about on our show. So do you have a struggle story or a challenge or a failure you can share with us today?
I think one of the most challenging times for me, and I see this a lot at Stanford as well with our students, is the time when you're going into your qualifying exam for the PhD program. So it's sort of at the end of your second year, you've taken a bunch of courses, you're trying to figure out what your project's going to be, you don't really know what it's going to look like. So I had a period where I was experiencing a lot of stress, a lot of anxiety about, can I do this? Do I want to be doing this? And was even experiencing some real anxiety attacks. It was a very unpleasant time in a lot of ways. I had considered, did I want to go back to teaching, which, didn't present these kinds of huge hurdles and stresses that I was experiencing as a graduate student.
Sure.
At that time in particular, a lot of your view of yourself can get wrapped up in how your science is going, which isn't very healthy. And fortunately, I think I'm experiencing much less of now. In terms of approaching that, it was everything from reaching out and getting some counseling to getting a lot of exercise, really getting out of the lab and getting away from the science. I played a lot of volleyball during that period just to burn off excess energy and get my mind off of the science. Played a lot of squash with a couple of really good friends, and that helped. It certainly didn't fix everything, but it made it easier to get by. And then inadvertently, I had already scheduled this travel to China to start my PhD project. So even though there was a lot of uncertainty about if I really wanted to be doing this and how it was going, I had booked a 2-month trip to China.
It was happening, yeah.
Never been to China. I didn't speak any Chinese. I had only met one of the people that I was going to be interacting with for 2 months in a fairly rural part of China. So I had to get on the plane and go. And it actually ended up being psychologically really good for me. It got me out of worrying about the science and just worrying about the day-to-day of going and collecting the samples that I needed to collect. And it was also just so different. The area that I was working in is one of the less developed parts of China. There's still a lot of poverty in the countryside there. And getting that broader perspective on the kinds of experiences that people are having in other parts of the world certainly helped me put my own experiences in a little bit broader perspective. It was also just a very intense experience of learning to speak a little bit of Chinese, of living in conditions that were quite different from what I was used to back in the US, and just having all kinds of wild experiences, from terrifying driving where the approach to passing other cars was basically just to lay on the horn, pull out to the left, hope there was no oncoming traffic, and put the pedal to the metal, to driving down the side of the road and seeing people with a dead pig running a blowtorch over it and thinking to myself, why are they doing that? It turned out that they're taking the hair off of it. To being out and having breakfast. For that part of China, I was one of the taller people that they had ever seen, and very few Caucasians spent much time there. So I got a lot of double and triple takes. And I even had a woman one day, as I was sitting out eating dumplings for breakfast, she walked by and she looked at me. And she wasn't that interested in me, but she looked at my feet. And she came over and started poking the ends of my shoes because she wanted to figure out if my toes really made it to the end of my shoe.
She couldn't believe your feet were that big.
Exactly. I had another day where I had a farmer come by and start chatting with me, and he quickly figured out that I didn't speak the dialect that he was speaking. I suspect that he wasn't speaking Mandarin, that he was speaking a more local dialect. So what he figured was that, well, if I didn't speak that dialect, the characters are the same for everyone. Mm-hmm. So he took out his stick and started writing characters on the ground.
Oh, wow.
And then he figured out that I was also illiterate and shook his head and walked away.
Gave up, yeah.
There are a lot of these kinds of experiences of just seeing how different the world was and how limited my own abilities and experiences were. That just sort of put me in a different frame of mind from where I had been beforehand. And it got me over the hump of the hardest part of graduate school for sure.
Absolutely. Well, Jonathan, I really appreciate you sharing your stories. I'm sure many of our listeners out there are currently at this point where they're at this existential crisis that is the qualifying exam or maybe graduate school in general. And I think hearing stories from successful scientists that they struggled too is really helpful. But we don't just want to talk about your difficult times. Jonathan, I'd love to give you an opportunity to talk next about one of your successes. So do you have a favorite success story you'd like to share?
Before we go to the successes, I think as I look back on it, the key thing for any listeners out there who are at a similar career stage is that if I had decided to stop the graduate program and go back to teaching, looking at it now, I don't view that as a failure at all. That also would have been a success. The expectation that I do a PhD was entirely my own. Mm-hmm. So I don't think you need to view the only success as getting past that and continuing with the PhD program. Any approach that puts you in a healthy place is great. When I think about success these days, it mostly has to do with the success of my students and advisees. And as a department chair, successes at our department level. So the big successes that I've seen over the past year are a couple. One is two of my former advisees ended up becoming engaged to one another. They're getting married next year.
Aww.
And one of them graduated earlier than the other and took a job in Houston. So they've been separated for several years. And just this year, one of them got offered a position at the University of Wyoming, a faculty position. And then the other got offered a position at the University of Wyoming as well. So not only are they getting to be in the same place again and getting married to one another, but they're able to take on the careers that they really wanted as well. So I'm just thrilled for them. Seeing those kinds of life successes, there's nothing better than that as an advisor. And at their earlier stages, I had two graduate students this year who published their first papers. Both of them got a little bit of press coverage. And both of them, I think, got some nice confidence out of that, of seeing that they really can do great work and that when you do good work, it does eventually get published and recognized. That was really fun to see these students kicking off their careers in the right directions. And then at the department level, we've been experiencing a big retirement wave of late. So our numbers have been depleted quite a bit over the last couple of years.
Gotcha. And
we just ran a very broad search in our department this year, and we've got offers out to 3 new potential faculty hires. And so we're working on recruiting them at the moment. So we don't know if we'll get all of them or not. But I'm really excited that the process led us to think very broadly and to look at some areas of science that we really didn't have many people working in before, but that we think are very exciting for the future, like the area of planetary science. So I'm really excited about that as well. So one of the nice transitions from being a graduate student to being a faculty member is, again, it's less about you and more about all the people that you work with. And it's really fun to celebrate their successes.
Absolutely. Well, congratulations on all these successes, both sort of in the mentorship world as well as the leadership role within your department there. I think that's awesome. And we talked about some of your successes, and I think those are so important to celebrate in science. but we also want to make sure we don't neglect life outside of science. And we talked a little bit about that in the beginning of our show. But I do want to touch back to talk a little bit about what you're reading these days, Jonathan. I love getting book recommendations from everyone on the show. So do you have a favorite book, whether it's a science book or not, that you can tell me and our listeners about?
I think what I'll do is actually flag a book that I just finished reading last week, which is a book called Life After Life by Kate Atkinson. And this is a novel. Essentially, it's similar to Choose Your Own Adventure in the sense that she tells the story of the life of one character in many different ways that it could have gone. Everything from essentially dying at birth, being strangled by the cord, to assassinating Hitler, to other things, and different ways in which she may or may not have survived the Spanish flu of 1918. So this is a woman who's growing up in Great Britain near London, to different ways in which she may or may not have gotten through the Second World War. And it's really, I think, well done in that by the end, there's not one privileged storyline, but there are a lot of different ones. Some you might say are a little better than others, or at least longer than others. But in none of the storylines does everything work out right. And you see the unintended consequences of different pathways. That this main character has a sense that she's getting second chances. So she doesn't have explicit memories of other iterations of her life. But as the narration goes, she, has these feelings that, something bad's about to happen, and these urges to take some sort of action. And that ends up leading to slightly different outcomes. And I think it does a nice job of highlighting both how small changes and decisions that people make or don't make can lead to fairly drastically different outcomes. But it also highlights the fact that some things are really hard to avoid, that nothing she does allows her to avoid experiencing the Second World War unless she dies before it. And similarly, a lot of storylines in the book end with her dying from the Spanish flu in 1918. And you see all these different ways in which you think, maybe this time she'll get through. And then she doesn't. And as a historical scientist who's trying to figure out why is the Earth now the way it is, and what events in Earth's past pushed it toward the storyline that we're on, and what changes might have had an effect or not in Earth's past. As a paleontologist and Earth historian, I'm always trying to imagine those alternative pathways because it's the only way of really understanding what, if anything, caused the reality that we're all experiencing. So to see this in book form, encapsulated in the life of one person living through a few key intervals in the history of the 20th century was really cool. And the book's well written. It's very well thought out. I wish I had had a little more time. I wanted to diagram all of the different decision points and how they lead to different outcomes, but I didn't quite get to that. But it's a great read. It's a combination of something that's thought-provoking and also very readable. You don't need to work really hard to digest every sentence or every paragraph. It only came out a few years ago. I imagine that there must be a movie in the works as well.
Well, Jonathan, I'm so glad you mentioned this book because I actually read it not too long ago and really enjoyed it. So listeners, you'll definitely have to pick this one up. Life After Life. Great recommendation. And earlier in our interview, we talked a little bit about some of the places you've been able to travel in your career. And I think this is one of the wonderful aspects of life as a scientist, and perhaps specifically life as a geoscientist. So is there a favorite place that you've been to for science?
I would say that first PhD field trip to Guizhou province in 2001 in China was certainly the most memorable of all of the trips, in part just because of how different it was from anything I had experienced before that. I think that if I had the same trip now, it wouldn't have quite the same impact. I'm at a different stage in my life. I've had the opportunity to travel to a lot of other places at this point. So what made it memorable? First of all, the friendships and the kindness of all of my Chinese hosts who tried to teach me as much as they could, as quickly as they could about Chinese language, about the food, the culture, who were very understanding when I was having GI issues every few days or every few weeks. 2 of the 3 most violent stomach illnesses I've ever had happened in an 8-week span.
Oh, no.
And a lot of it comes down to sort of very specific memories that are unusual. The first day that I got into the town, this must have been late July, 90 degrees, humid. The guest house only had running water on the ground floor. It only had trench toilets. There were about 3 stalls where you could all squat down next to one another. I was up on the 3rd floor. The trench from the toilets ran out between our building and the next building, so my window opened right onto that.
Oh, wow.
So I got there and I was really wondering, what have I gotten myself into? Wake up the next morning about 6 a.m. with firecrackers going off. It turns out that there's a funeral because someone had died recently. So that was my quick introduction to the funeral experience there. And at first I was just looking at this and thinking, how am I going to live here for 8 weeks?
It's been 24 hours, right?
But it quickly turned around. It became a really fascinating experience because it was a very small town at that point, probably a couple thousand people. To eat breakfast, we just went down to the noodle and dumpling shop on the corner, and we would sit outside, which is what everybody did. So you would order your dumplings, your noodles, and we would sit out at this little table right on the corner of the main intersection in town and watch people go by and eat our breakfast. This is where I had this woman walk up and start poking the end of my shoe. Right. There was a day when the local bus was coming through, and I guess it was a dead horse that they were trying to load up on top of the bus to take somewhere. And one person was working on this. I'm trying to remember the specifics. I think they brought it in on a cart or something like that. Yeah. But I do remember a couple of people getting off the bus just to help out with that. And
like no big deal. Yeah.
It was only a big deal to me because this wasn't my usual experience. After 2 weeks, they opened up a new guest house in town. So then I actually ended up staying in a newer guest house, which was more comfortable. But it didn't have showers that worked yet. So actually, at the end of my field day, I would come out, get my dirty clothes and my flip-flops, and trudge across town, right across the main intersection over to the old guest house so that we could go and use the shower there on the ground floor, which basically consisted of a bunch of stalls with pipes and a valve. So you just pull the lever on the valve and the water would come out, and whatever temperature it was, that was what you got. So I have vivid memories of just walking back and forth across the main intersection in town. Mm-hmm. And then on a day off, for example, I went over and found the local elementary school just behind the main square. So when I went out there, a few of the students started yelling "Lao Wai," which is, as I'm told, not a terribly kind word toward foreigners, but I don't think they really meant it that way. And within like a minute and a half, I had probably 50 or 100 kids standing in a big circle around me.
Oh, wow.
It was just an amazing experience. I ended up the next year going in and actually visiting the elementary school and doing a little English lesson for them, which was really fun.
That's cool.
And I was there during the September 11th attacks in the U.S. So given the time difference, I had gone to sleep. And it was around midnight when our driver came, knocked on my door and woke me up. He didn't speak any English. So he comes and wakes me up. He's clearly pretty agitated. I couldn't figure out what was going on. And he just goes and he turns on my television, turns it to the news. And I see a picture of what were obviously the Twin Towers. And I see that one of them's on fire. But it was the Chinese broadcasters talking, right? So there's no English language to listen to.
You couldn't understand, yeah.
And then it was a half-hour news broadcast, and this guy had woken me up right near the end. So I got a couple minutes of this, and then it ended. I had no internet connection. He didn't have enough English to tell me anything useful. So I went to sleep sort of knowing that this must have been something very bad, but there was nothing I could do about it, and there was no way to get any more information, at least until the next day. And the next morning, I talked to one of the Chinese geologists who was working with us who spoke a little more English and helped me figure out most of the basics of what had happened. And we figured out how to make a phone call back to the States. Essentially, that year, mostly what we were doing was driving an hour and a half and using a telephone in a city an hour and a half south of us where you could make international calls. But it turned out that because of all the phone traffic after the attacks, it was hard to get a call through. So Andy Bush, who's now a professor at the University of Connecticut, my memory is that it took us a number of tries and maybe even a couple of hours to get through. So he got through to his family and I got through to my family eventually. And that was when we really got filled in on what had happened. And there were no flights going. There wasn't really much point in going back to the U.S. Fortunately, neither one of us knew anyone who had directly been impacted by the attacks. And there was nothing we could do about it.
Sure.
So we just continued with our work. We were able to make a couple more phone calls back every couple of days just to find out a little bit more. But it must have been around the 23rd of September that we took a 36-hour train ride across China. We were bringing our samples to Hong Kong to load them on a ship to ship them back to the U.S. It was when we got to Guangzhou, which is a major city, just an hour and a half train ride from Hong Kong. And we stayed at a big modern hotel there. It had a Hard Rock Cafe in the basement. And I have two vivid memories of that. One is going into the Hard Rock Cafe, and we were just staring at all these other Caucasian people who were sitting around innocently having their dinners there because everybody that we saw for 8 weeks was Chinese. Mm-hmm. And we, of course, were very frustrated about being stared at all the time for not looking like everyone else. And then First thing we did was, of course,
gawk at everybody.
But the other favorite thing was that all of a sudden we had access to BBC. So we finally really got caught up on the news. That was, of course, also the first time that we didn't have a squat toilet in the last 2 months. But talking to Andy afterwards, I think both of us feel like in a lot of ways, psychologically, we're actually very fortunate to be in China at that time. That for both of us, we've always felt like the impact of that event has been less on us than on our friends who were in Boston or in New York or in DC at that time, because we had no option of watching the news 24/7. And life in China did not shut down at all after these events.
Absolutely. Well, and I think it's so great to be able to travel, to expand your horizons, to kind of get outside of your comfort zone, like some of these stories you were telling, but also this story that you shared about experiencing a moment in history from the perspective of a different culture. Like you said, life went on and sort of distanced you from that phenomenon. So I think that's very interesting perspective to have on the September 11th experience. And then also just some of these, I guess, quirky cultural things that I think we take for granted in the life that we live every day, that we have these maybe modern conveniences and things that you were suddenly without on this trip. So
yeah, that was quite an experience. And I think the other thing was these friendships and the cultural struggles of learning each other's languages. This was before there were digital dictionaries and those kinds of things. So we had a field assistant, a guy named Yao Han Long, who was working with us, and he knew a little bit of English, and he was trying desperately to learn more English. And he had this red Chinese English dictionary. So every time he wanted to say something where he didn't know how to say it, he would flip through the red book until he could find the word that he was after. One time I was taking samples and I chipped off a bit of rock and it hit my knuckle and I started bleeding all over the place. So I was swearing and getting out the medical kit and trying to clean up my hand. And Xiao Yao, instead of helping me, right, he runs to the dictionary and starts flipping through it. And as my hand is finally cleaned up and I've got the Band-Aid on and I think the bleeding is under control, he turns to me and says, "John, I am deeply grieved." We haven't managed to cross paths again afterwards. We had a big banquet at the very end of that field season. So I'm shaking hands with Xiao Yao and he says, "John, next time we will play different intercourse." And that was the last thing he ever said to me, at least to date. I have a vague sense of what he might have meant, but it was...
The phrasing. There's something about the phrasing, right?
Yeah, those parts of it were really fun. And I'm sure that I did exactly the same thing to him with some of the things I tried to say in Chinese.
I think oftentimes things are lost in translation, but that's part of the fun, right? Yeah. Well, and I love some of these stories that you shared and how they highlighted some of the people you've been able to work with, because I think there are so many funny, amazing, creative, wonderful people in science. And I love sharing stories of some of the great things that you do when you're together. So do you have another story of a lab tradition or perhaps a funny memory that you'd like to share?
The one thing that's been really fun for me over the years is really this long connection that we've had between the group in China and the group in the US. So we have had a tradition over the years of having research meetings every year, a couple of years, and getting everyone back together. So we were really fortunate. I guess it was just last year, we were able to get everyone to Stanford for a meeting, including Paulinus and Wei Jiayong, who were both in their mid-80s. And it was wonderful. They hadn't seen each other in about 15 years. So it was great to get everyone together and to share stories. Paul did a slide presentation showing slides from the late 80s of the initial fieldwork in China. Mm-hmm. And sadly, Wei Jiayong passed away just a couple months ago. So I feel really fortunate that we've had this tradition of getting everyone together. And certainly for all of us who are still around, I hope that'll continue for a long time to come.
Absolutely. And I love that this collaboration has survived multiple generations of scientists, as you said. That's wonderful.
It is. It's more like a family than a scientific collaboration at this point, which is fantastic.
Well, that is wonderful. It's great to hear about this long-term connection that you formed with this research group. And I know you're answering a lot of phenomenal questions in the work that you do, but I imagine there's a thing or two standing between you and that perfect question that you've been dying to answer. So Jonathan, if we gave you all of the funding, the staff, the technology, the feasibility, the resources, whatever you need, what is the one question that you most want to answer right now?
There are two that are related. The one that I think nobody is really working on right now that would take a lot of human power to go after is that I would love to know the sizes of every species or even of every organism that's fossilized across all of geological time. We've been working on this in my lab for the last 12 or 13 years. And each summer I bring in high school students to help with the data compilation side of this. So they go through published literature and they get out digital calipers and they measure fossils and they enter the values into our database, supervised by a research scientist. A guy named Noel Heim in our group is wonderful. And This will be the 6th summer that he's doing it. And we had sort of earlier versions of this before Noel got here, but it's stepped up a lot. But we're trying to figure out how we can get sizes for everything, meaning every fossil in every museum collection, every fossil that's illustrated in the published scientific literature. And we're trying to figure out ways to accelerate this. Right now, it's human power. But again, some of the machine learning technology these days should allow us to be able to measure all these pictures. There's a big challenge of taking the measurements, knowing what part of the fossil you're looking at, reading the text to understand which species is it, and all those kinds of things. But if I had all the funding in the world, I think there's an enormous amount we can learn about what controls evolution on Earth from understanding the sizes of organisms. That, I think, would be the one that I would go after, given the time, staff, and technology. And then the next thing I would do is to measure the isotopic compositions of all the limestone samples across geological time, which can tell us a lot about the environments and would help us understand why the fossils are the sizes that they are.
I like it. Well, Jonathan, these are both very ambitious projects, I must say. You're dreaming big here. Well, phenomenal things for us to think about today, me and our listeners out there. And I think you've given us a lot of insights and a lot of food for thought throughout our conversation today. But one last thing that I would love for you to impart to our listeners is a piece of advice. Is there one piece that really helped you that you can pass on to them today?
I think the most memorable piece of advice is the advice that my dad gave me, if not every day, at least many days as I was heading off to school, which was don't bite the teacher.
I like it. That's good advice. So was this a problem that he was worried about, or?
This was his sense of humor, and I think I've inherited it. I've never bitten the teacher. I think the underlying message was that you're going to be fine. So he liked to have some fun with that.
It's also similar to the don't bite the hand that feeds you. They're feeding you knowledge. So, right.
I think so. I'm not sure that he meant it that way. I think it was much less serious than that.
I like it. Well, wonderful message to give our listeners. If they want to learn more about you and the wonderful work that you do, Jonathan, where should they go or how should they get in touch?
They could find my lab website. I don't have the URL in front of me, but if you search Jonathan Payne and Stanford, I'll come up pretty quickly at the top of that list. And my email address is listed there as well.
Perfect. Well, listeners, definitely check out the website. Jonathan has so many cool projects that he's working on, and get in touch if you have any questions. And Jonathan, thank you so much for your time today and for sharing a piece of your story.
Thanks for having me. It was a lot of fun.
Well, it was a pleasure to chat with you, and listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science.